All right, welcome to DevOps World. I'm Ben Walding, presenting on hybrid cloud continuous delivery. So this is a bit of an overwhelming presentation option compared with some of the other rooms, so bear with me as I get my bearings. You'll see I've got a Twitter account, but it's probably dubious whether that should be followed or not. My focus generally for these kind of talks is technical, but my background is technical, and I love a bit of road cycling too. So that's the what I do on the Twitter account. A bit of snark too. So that'll probably come across in some of the examples and things that we cover today. In case you hadn't realised, yes, I'm Australian. I'm not a New Zealander. Not that that's a bad thing. No jokes about kangaroos, Vegemite, prawn and barbecues. But we do love big stuff in Queensland, which is where I'm from. So the big pineapple is a big favourite. We've got other big things over there as well. So just a little bit of background, make me more of a human to everyone. And so in terms of when we get down to the technical side of this presentation, I'm giving you background because it's not a war story, but it's a bit of a description about how we got where we are with CloudBees. And if you're in a smaller startup and you're moving towards to becoming a bigger startup, which is what we hope for everyone, then this will be sort of interesting to you. If you're in a bigger corporation like PayPal or something like that, then you've probably been through these growing pains already. But that's where we're coming at from this talk. So I joined CloudBees in 2010, back when there was a handful of engineers. I was in the first wave of non-founders and brought to CloudBees, the code house. Basically, I was one of the chief dev spots on code house. Did all of the changes there. So if you've ever used code house, you'd probably know my name, maybe. But if you hadn't, it was very similar to SourceForge and sort of more recently what GitHub and Bitbucket and all of those are offering. So I brought that skill set and some of the product suite to CloudBees. And then over time, I took on more operational responsibilities and put in place process and various things like that to basically take us from a very much like a startup DevOps culture to a more rigorous operational culture over time. We still DevOps, but it's different. It's not engineers poking around on production servers or even writing every last job that runs in production. My team takes care of a lot of that infrastructure. So yeah, like I said, it's a combination of DevOps for some systems and more managed systems for other things. So if you were here at the keynote, you would have seen DevOptics, and that's one of our new big SaaS products. And so they've got embedded operations engineers in the team that then talk back to my team and make sure everything's aligned, but they're a lot more responsible in that platform for what's going on. So we, in terms of this talk, it's a small to medium kind of talk that I'm presenting today. We're not talking about thousands of masters yet and hundreds of engineers. It's a very different challenge when you're trying to solve that problem, which is what PayPal was talking about earlier in the DevOps theatre. About how they had 1,000 Jenkins masters and that kind of thing. So yeah, we grew from 1 to 10 technical staff and then to 100, but not up into the thousands as yet. And what we found is that every 25% increase in staff in general radically changes how you operate. So you'll put on, maybe not at the early stages when you put on 2 or 3, but if you put on another sort of 5-10 engineers, there's all that onboarding and all of those processes, and they need to learn how you do things, and that that operational culture, especially if they've come from maybe open source or they've come from a small startup and they've joined a bigger startup. They need to learn those new practices, like any company. But I think that there's more challenges when you join a bigger company and you have to deal with corporate IT and InfoSec and all of those things. So that's the kind of challenges we were facing. So when we started out on the first wave of products for CloudBees, we did a product suite called Debit Cloud, and it was a Jenkins in the cloud, basically, a hosted Jenkins running on Amazon Web Services. It predated Docker containers. Docker, I think, was around 2013. They released the first alphas, so we were ahead of that. So we had shell scripts and all kinds of not containerization, but compartmentalization that we used in the early days. We were located predominantly in US East 1, for better or worse, and we had a bit of regional failover into EU West 1. But you know what? We tended not to fail over anyway. Amazon, even back in the early days, would tend to solve things faster than you could do a real migration. So we tended to wait, except for that one time in 2011, EBS failed, and if you've ever seen EBS failing, you're dead in the water. You can't do anything, can't snapshot, can't clone volumes, and it was bad. Like, I think it was 2.5 days of outage on some of our volumes. And people go, well, if you were running in another region, you would have been fine. It's like, you couldn't snapshot unless you were doing replication in real time. From US East 1 over to EU West 1, you were going to be struggling to do that. So we didn't have a solution, but you know what? The rest of the internet was basically down at the same time. That's what it felt like. I was seeing all these other startups with the same kind of issues. So that was what we found. And it's a different cloud now, in my opinion, and what we see operationally. Issues are fixed very fast. You see there are the occasional thing where it takes them half an hour and then they say green tick. It's like, yeah, it's not really green tick. Not everything's working just yet, but it's different now. So we had an evolution of instance builds with what we were doing. Bespoke shell scripts for everything. That didn't last long because it was just painful. You had to write a lot of error handling and things like that. And Chef was on the scene, so we migrated to using Chef pretty quickly, and that was good enough for a long time. 8 years, we're still using it. And Debit Cloud's still operational at the moment, and Chef is in use on some of the platform. Then we switched to a bespoke. Back to bespoke for services, but this time we had a better idea of what we were trying to achieve, and we sort of built libraries and things in shell script. And I don't know whether you'd say that was the right decision or not. It's lasted for a while, and it's easier for people to pick up if they're not Chef people. Then we went to Ansible, and that's been moderately successful. Packer for more AMI-based capability, but then we use a bit of Ansible in there to do some of the legacy bits and pieces. And more recently, we've just gone container. Obviously, the last three don't overlap perfectly. You don't use containers at a base AMI build, so we use a combination of different instance build technologies depending on what makes the most sense. So I thought I'd break away from that and just talk about my maxims of what I like to see in operations. And I like to say, don't fight the framework. If you feel like you're doing something a bit ridiculous or it's a bit painful, make sure that that's actually the way you're supposed to be doing it. Reach out to developers on IRC, and whether it's Jenkins or whether it's Terraform or Vault, don't bash your head against stuff and try and do it a different way because that's the way you like doing it. Because what will happen is that 6 months down the track, they'll change it underneath you and you won't be able to upgrade anymore. Whereas if you're doing it the way they wanted you to do it, it's usually an upgrade path that you can follow. Things like Go format. The first time I used it, it's like, who uses tabs? And I'm sure there's half the people here use tabs. But if you fight it, you're just going to have a bad time. So we just went, no, that's it. We'll just go straight to using tabs. We'll use Go format, and that's been the right decision for us. There's not even a discussion about it amongst the team members. They just go, you format the code with Go format or don't check it in. So it's simple like that. My other one is stop me from doing the stupid thing first. I am not a Jenkins expert. I don't write a lot of Jenkins code. I work for CloudBees, but historically I might have maintained quite a few thousand Jenkins instances, but I'm not a Jenkins expert. So I will go out and try and do things the stupid way first, because I'll read a blog post, but the blog post is old. What I've learnt is that I've got a team full of engineers. I just post on the internal list, is this the right way to do it? And I'll get the better way to do it first. But what I want to see from products is the ability to know what to do the right way the first time. And so if you're writing a product or building something for customers and they talk about user experience, try and guide them in that right direction the first way. And internally we write products for our engineers, and so we like to make sure that they do the right thing the first way. We try and stop them from doing the stupid thing first, because that means less tickets for us and a better experience for everyone. AWS MFA, so that's multi-factor auth. We basically stop our engineers, or we try and help our engineers not to make the bad mistakes first, and not use MFAs and hard coding credentials. So we don't issue them user accounts over in their administrators in their AWS account. They don't have AWS credentials over there. They've got them in our central IAM repository, IAM account, and they assume role. So we use the infrastructure the best way we can. So then the IAM roles production usage of the system. So we can also basically, with our production usage, we try and make sure that they do things that make sense in production earlier in the process. So if you're doing something in development, make sure that it matches up to production. Don't let the engineering teams go off and build some kind of crazy thing that works in development because they can support it over there, and then when it gets to operations, we turn around and go, you know what, we can't support that anymore. So we want to get our team into development as early as possible. We have engineers from my team in those early stages, whether it's in whichever cloud it is. And it can be tricky because with hybrid cloud, you may not even realise that they're using it. I got a ticket the other day. Oh yeah, most of it, we don't know how to get a corporate Google Cloud account. And it's like, okay, so what are you doing? Oh, we just provisioned our own Google Cloud accounts and we're using it like that. And it's like, okay, we'll have to deal with that. But if they're able to do that, then they're also able to introduce technologies that you can't support in that hybrid cloud environment. So that if you can inject your engineers earlier in the process and don't make it like corporate governance is coming down the line to stop them from doing things, then you'll get a lot more buy-in from the engineers. They'll talk to you. They'll trust you that you're not going to just shut them down, that you're going to help them. And the final one of my maxims is just don't underestimate the 800-pound gorilla engineering teams. AWS, hundreds of engineers, thousands of engineers working on things depending on which product line. You can build your own sort of little piece of the stack in the hybrid cloud that, we built this thing that is better than AWS at this one thing. It's like, that's great. Are you going to be supporting that forever? And it's only just a little bit better. Things like Elasticsearch. Sure, you can build your own Elasticsearch server, you can host it yourself, but you know what? Amazon's got people doing that, and they're specialists, and they're doing it all the time, and they see thousands of customers having issues and that kind of thing. They can solve problems quickly, so don't underestimate the power of cloud providers there. all I've been talking about is AWS, but this is where we came from and how we scaled from 1 to 10 to 100 engineers or technical team. We're getting there. So yeah, we talked about that technical team growth, and then we switched clouds. Oh, we didn't. Sorry, that's not what happened. We didn't switch clouds. We used AWS for production, and then we started to use Azure for non-production use. We got customers who were using Azure, and obviously when I say Azure, I mean Azure, as everyone else in the world pronounces it. We're special in Australia. And so, yeah, we started to see use of Azure in non-production context for development. And then Google Cloud is a much later addition to our stack, especially with Jenkins X. So Jenkins X is all the talk of the town, and we're now starting to see like a push towards production for Google Cloud. So we'll be there very soon. But it's not to be underestimated. Hybrid clouds are expensive to operate. I mean, they're not the same. You've got to train your staff differently, different IAM across the different platforms and different ways of doing even the most simple things. So you've got to really understand what you're trying to do, and that's why we pushed back. It wasn't anything to do with like technical requirements and constraints with Google Cloud. It was all that we just didn't want to. I didn't want to fracture my team across multiple clouds badly. We understood AWS. We were good at AWS, but now that we're starting to see Google Cloud for us become a production environment, now we're going to train up and implement it the right way. So we found some problems as we went to this hybrid cloud environment. AWS was inconvenient to restrict marketplace, and if anyone's ever had given administrator access to an engineering team and had sort of people clicking around, they may have discovered that it's really easy to spend money in AWS. We had one case where a team member was interested in Teradata, and he clicked on the Teradata one click, and I got an email from finance saying, "Oh, you realise you just spent $16,000 up front, no refunds," from finance. We got a refund from AWS, but they said don't do it again. So not long after that, we locked down AWS Marketplace in our accounts. So it's possible to restrict it, but it's quite inconvenient because it's not very granular. You can't do per SKU restrictions, as far as I'm aware. Some of these might be out of date. Azure AKS, when you create a resource group, you end up creating a shadow resource group with all the nodes in it. Unfortunately, if you've got a lockdown account, you grant access to your engineers to access the main resource group. They create an AKS cluster, and this shadow resource group pops up, and they've got no access to it. So it makes management of that more difficult. There's open tickets on the Azure site with people complaining about it, myself included, and there doesn't look to be any movement from Microsoft on that. So, but they're aware. It's relatively straightforward to manage. You just have a bit more process, but it puts a big sort of spanner in the DevOps work that we're there. Google, haven't found anything too bad in what we've done so far. We just grant administrative access down to the users, and that seems to work well. We do it at a folder level, so they can create their own projects and structure things in there for themselves and go that way. The next sort of thing I'll cover is the automation infrastructure. What we found is that it was very helpful for us to build out automation for the things that we wanted to do. So we made it a strategic decision, and we said we're going to build it, basically a CLI to our platform. And that included things like Google, it included our GitHub, it included our Debit Cloud platform, it included everything. And we used that to tie everything together. So when a new staff member starts, we go download our internal tooling system, which is called OpsCore. operations core library, and they can then interact with the system, they authenticate and go through there. And we chose Golang for that. It seems to have a good mental fit with operations engineers in terms of development and writing code, and there's lots of operations engineers out there. Google's very operationally focused. It was cross-platform, not in the same way as Java, but you can target the three core platforms for us as developers: Darwin, OS X, Linux, and Windows. And so it was good from that perspective. And reliable libraries. The people who write Golang seem to be of the same kind of mindset. They build things the same way, and they learn from other libraries, so it's been good like that, and good sort of base things to learn, and lots of bindings to all different platforms and APIs. Generally, you'll find a Golang API client for most things. We focused in our automation tooling on automation that related to authentication and security. So rather than engineers having to understand necessarily the underlying way that Amazon STS works, which is the IAM, part of IAM, we built layers on top of that which knew about our infrastructure. It knew about our accounts. It knew who they were and where they needed to go and what kind of roles they should be using. So automated all of that. Automated rotating credentials. So if you filled in a security certificate for a security review for a bank, they'll go, do you enforce credential rotation? And everyone says, yeah, they do, but there's all kinds of places where it's not necessarily enforced. So, and the reason it's not is because it becomes difficult. And so you make it easy. Make the good things to do easy. Stop them doing the stupid thing first of hard coding credentials. Make it easy. So one command, rotate the credentials, and they're done. And from a DevOpsing perspective, we orchestrated support access to systems as well. So the engineers don't necessarily need to know where the service lives. The level 3 engineers do. They know exactly where it lives, but a support engineer doesn't need to know where the service lives. They're interested in the logs. So we don't make them look that kind of thing up. They've got a command line that they can run, and it'll go and look up where that service lives, pull the logs, and do things that need to be done. And that can work across the cloud. So as we move to we've actually got bits that talk to Google Cloud already, so we're starting to orchestrate things over there. And all the engineers will do when they hear about a new feature, Ops Core update, and they pull down the latest command line interface, and they've got that capability straight away. So these are my suggestions. Make it a strategic deliverable for your hybrid cloud is that management layer. When we first created our command line interface and automation infrastructure, it was a concept, and I'd read a blog post from 2012 by 37 Signals, and they talked about what they'd done, and it was a good idea, and we sort of went, oh, well, we should try this and see if that works. Yes, it works. It works really well. You can build in all kinds of things that you never thought you would need. We do things like a VPN check. So when the engineer says VPN's not working, and they can run a VPN check from this binary, and it checks DNS is working, routing's working, tunnel interfaces are all configured. It's cross-platform. We've got engineers on each platform in the ops team, so they've built that capability across the different platforms. Planet. I was having a discussion today with one of my engineers, and he said, "No, it's very ad hoc the way we add new functionality," and I agreed completely. And that's one of the things is it becomes sort of like a snowball, and you keep packing extra bits onto it. But I think at some point it grows to a size where you really need to treat it as a project. It's a deliverable of operations. Is this command line tooling and automation interface? If it fails, your engineers are dead in the water. So you make sure it's tested. You make sure that you've got release planning, and it can all be automated, especially in the ops team, because you've got access to everything. You can make sure it's nice and smooth like that. So, and the sort of the group of suggestions is design the CLI. Think about how you structure your automation. What kind of things would engineers need to do? Use it as an opportunity to add syntactic sugar on top. So don't make the engineers remember an AWS account ID. No one wants to remember that. They want to remember the name that you've given the account, or the project in Google, or the alias in the Google Cloud project, or the resource group, or whatever asset you're trying to reach. They want to remember it by a human name that doesn't change if the underlying structure changes. Make it auto-update within reason. We've got a manual command that we run because I don't want to run that right before I do a production release or do some kind of crazy change that I don't want to fail. So we have the auto-update capability. OpScore update, bang. Now, there's no new version, nothing happens. Oh yeah, there's a new version. And it is checking every day to see whether they're out of date. So our support teams sometimes come to us and go, oh, this doesn't work. And it's like, well, are you running the latest version? And they go, oh no. And then they update, all fixed. Yeah, we fixed that weeks ago. You should have updated, but yeah, so it's not they've got the same thing. They don't want to destabilize their environment. They want to control their updates. So we use that. Lots of testing. Don't just treat it because it's a bit of a shell script kind of thing that you don't have to test it. It's a project. It's a deliverable from your operations team. It helps you work across the clouds, and it's all in. Don't use it for half the stuff. Use it for everything. And once you've got all the process tooling around it, it'll really help that hybrid cloud capability as you go, oh, I need to know this about Google Cloud. Oh yeah, it's all in OpScore. There's one binary, there's one version number. You don't have to ask, oh, have you updated the scripts over here? There's nothing worse than someone telling you, oh, yeah, that library, you need to update it. No, it's one binary. It's a big binary, but it's one binary. What we found is with hybrid cloud, wide range of skill sets on engineers coming into the environment, wide range of skill sets within my team, and so we want to make sure that the automation tooling levels the playing field in a sense. So someone new coming into the environment is fully functional and fully productive much sooner than if they didn't have these tools. And so we have things built into our tooling, which is like a setup script, Golang code, it's not script, so it's set up, and they run that when they start, and it asks them a bunch of questions, and they fill that in, and then they're done. And that was a lot later that we introduced that, but it was after lots and lots of queries from engineers going, oh, it's not working. So we added automatic setup, with a few questions, and a check routine, which just basically, on their laptop, it just checks the entire environment. Do you have this? Do you have that? GPG installed? Are your keys set up? Is your AWS set up? Is your Google Cloud set up? Microsoft set up? And once that's all done, they get the green light from OpScore, and away they go. And so that's really useful if you're an operations engineer. You can very quickly go, have you run the check? And they go, no. And you go, run the check. And it comes up. There's 20 lines. They're all info except for this one red line, which is an error, and points them back into Confluence or your wiki or wherever, going, this is how you set this up. It's not part of the automation, or you've got this issue, and it very quickly nails it down. Security, yeah, just like I said before, raising the baseline on security for them, so making sure that they're doing the right thing the first time, not putting credentials into programs, into their code. I mean, it sounds basic and obvious, but it's so easy to do. It's so easy to put an API key in your Java code, but don't do it. It's bad. Assume that all of our containers are published on the internet. Just assume that, and don't do anything that you might not want to see out there. We don't, but assume that. And yeah, I covered the OpScore check a moment ago. So in terms of the hybrid cloud management, we manage teams with in-house synchronization from Google account to Azure. So that basically scans Google account and then updates Azure. You have to remember some of the things that we do. We've been around 8 years, not long in a corporate Fortune 500 kind of example, but for a smaller startup, that's like a lifetime. You've had turnover of engineers and things like that. So Google is much simpler from a hybrid cloud perspective. You just integrate, you just add their email address, and they've got access. So we started off adding single users. That's annoying. So then we switched to using the groups. The Google account group stuff sort of rubs me the wrong way. It's sort of like it's got this list sort of thing tied to it, and we didn't want that. We just wanted the pure group management, but it is what it is. And at an administrative level for engineers, in a non-production sense, we grant full administrative access to the AWS accounts, full administrative access to resource groups, and then in Google at the folder level as well. So we like to grant that level of access because it unlocks engineers. There's nothing worse as an engineer, and I've been there. I can't do something, I don't have access. I'm just doing development. Why don't I have access to do that in development? And we operated that way for a while, and it just doesn't scale. You need to have engineers available, operations team available to change permissions like within 10 minutes, otherwise it blocks the engineer. So we let them run amok in their non-production accounts, less so in production. So everyone says it, security is important to us, and they usually say it right after they've been breached. And that's not a good time to be paying lip service to security. So what I would say in the hybrid cloud context, use the capabilities of the cloud. If you use the clouds in the way that the providers would prefer with temporary credentials, they're a far cry from where they were back in 2010. AWS, you had static credentials and multiple accounts were quite difficult to manage, and things have come a long way. Use the security groups in the cloud, whether it's a Amazon cloud or a Google or whatever, and train your engineers. Engineers are probably the weak point. They love to load up software and run stuff in their accounts where they've got administrative access, but help them do the right thing. Stop them from doing the stupid thing first. And it's not because they're stupid. They're all smart, but they want to get things done. So put on your empathy hat and think about why other teams are doing things the way they are, because that's the key. When you can think the way another person thinks, it helps you understand and deliver services that they need. Security, the environments. We like to use isolation. A lot of this is I've spoken to. Basically, keep them isolated across the clouds. I mean, you can link your production environments, but definitely decouple non-production and your production. So in Amazon, that's fairly straightforward. Use different accounts, and some people go, "Oh, we've got resource level security. API limits aren't limited per resource. They're across the account. So if your development environment goes crazy and wipes out your API limit, all of a sudden production will grind to a halt, and you don't want to be there. Train your engineers. The other issue with as you get the sprawl across the clouds is waste management, and biggest issue we have, resources left running. And you'd know that if you don't have automation cleaning up. So we have our Chaos Steamroller, which is like the old Chaos Monkey of Netflix. Basically, it just it stops instances that don't have an owner attached to them after 7 days. So yeah, they can run for 7 days, but we can shut them down and stop resources running away. So it's always a challenge to get your engineers to think about taking ownership of their resources, because they're trying to get stuff done, they're trying to get work done. So help them, and then if you need to use the steamroller, make them understand why you're doing it. And you know what, I had a lot of pushback in the early days when we said we want to do this to your account, and then after a while we switched it off for some reason, and I got a call from someone going, why aren't our instances being stopped anymore? They'd come to rely on it. So, and for the engineers in CloudBees, great news. At the end of the conference, we're stopping all your non-production services. So it's a bit of a surprise for them. Not tomorrow, but in a week or two. And so the idea there is there's a lot of stuff out there running, people who didn't put their name on it, no one knows who owns it. So they'll go and put their name on a few things, and then we'll shut down everything else. Continuous delivery pipelines. We've got lots of accounts, lots of Google folders and projects and various team structures, and so we use the segmentation to basically control where data can come from and where it can flow to, and basically do it at a team level or a squad. There's a lot of new naming that's being used now. So from the point of view of our one of our sort of canonical examples is an AMI release process. So it spans 4 phases. There's sort of team aligned, basically development or engineering. QA gets the AMIs, tests them, and then release team gets the AMIs, and then operations gets the AMIs to do the final release processes into the production gold master accounts. So I've got an example on a following slide about how that might work. And then, automate that low-hanging fruit first. Some things are quite difficult to automate, and you go, oh, I don't know how I'm going to automate that. Don't automate it, just do it manually. And then eventually it's going to irritate you so much that you automate it. So we often say we hire people who don't want to do a lot of manual work. This is a good thing for anyone who's doing a lot of DevOps or operations or automation. If I get a ticket to do something once, I won't automate it. If I get that ticket every day, every week, for months, guess what's getting automated? That thing that I hate doing. So, so we've got the build dev AMIs. We test them, we promote them, and then that's via our Bastion Jenkins, which has got elevated security, and then that goes out into our production AMIs. So that's like a general process that we use, and the Bastion Jenkins is controlled by operations, and we control the security, and there's no sort of engineers with admin access on that. They can go and run things if they want. It's all through my team. So like when we talk about hybrid cloud, we've got a lot of Jenkins out there. We're the Jenkins company. So we've got Azure, and we've got Kubernetes on GCP. We've got our CJE V1, and you know that now as CloudBees Core, runs on Mesos and hosted on AWS. We've got V2, which is Kubernetes on AWS, and then we've got our Bastion Jenkins, which is just a vanilla Jenkins Enterprise, and that they attach to all the different resources. So, and then they talk to like the various resources in the cloud, so they've got access there. I'm just going to speed up a little bit. So we've got a monitoring and alerting. You need that. And my recommendation for monitoring and alerting is use a provider to help you with that. We use Datadog at the moment, and that seems to work well. But it lets you get up and running with a lot of different monitoring. You monitor your whole cloud. You get information coming in from everywhere very quickly versus trying to build your own or use the dashboards in the clouds. You use CloudWatch over here and Google Monitoring over here. It's too difficult. You need it all in one place or you won't use it properly. So that's like an example dashboard. That's live. That's why there's stuff. Sorry, it's not live, but it's from our production system. And I've blurred out things because if I didn't, I'd be getting snarky Twitter messages from people going, "Oh, you showed this up in the demo." So basically names of servers and things like that. But we can see how much memory is available in the cluster, because when they start running a lot of PRs, memory drops down, and then you start builds queuing. So we can see from that whether we've got enough infrastructure. Is it a prolonged limit or not? We use security auditing, so we in our automation infrastructure, we do audits of various attributes across the cloud. We add those checks to our tooling, tighten the screws, so we add a new check, everything goes red because it's now failing that check, and then we go through and clean it up. So we use the CIS numbering scheme, and we work off those corporate InfoSec checks. Use the platform, AWS GuardDuty, very interesting product. It scans like your AWS accounts, checks logs, CloudWatch. It finds a lot of interesting things that you didn't know. It could even see, it finds them. But yeah, how's it hybrid cloud? Because you want to use the platform. Use the platforms that are available to you. A lot of the time, there's teams of engineers working on GuardDuty, whereas you'd have to write every check yourself, and you don't know what you don't know. So. From our perspective, our security auditing, we have we run them as Jenkins jobs. So item 1, you can see that the OpsCore account audits, there's failures in there. One of the engineers just added a new check, so we got some failures, so they're now going through and working with the teams to lock that down. Item 2, you can just focus in on the failing jobs, find out what's failing today, what you need to go and sort out, and you can see we do network checks and VPNs and everything, all our auditing there. So we've added lots of strict checks, and they're now failing. Those are all accounts there. So we can see which accounts are now failing the security check. It's not a bad thing. It just means that they may not be optimal. You may be missing a password expiry date or something like that. Manage configuration drift as well. So we have our configuration managed via Terraform, and then less so for other clouds. But my recommendation, use provisioning tools as early as you can. As soon as you know you're going to use another cloud, get onto it with a provisioning tool. It'll save you in the long run. And we run Terraform every hour on every environment to make sure that they haven't drifted from our state files. So there's nothing to show you. Everything was sorted out last night when I went to check and do the final slide. So yeah, they fixed everything. Good work, guys. Can't show any failures there, but that's a good thing. My conclusion, I think hybrid clouds are unavoidable. I think they are difficult, but they are unavoidable. You're going to have teams that want to use services, and it's going to be organic. You probably won't even know when they start using it. They'll load it on their credit card and go from there. And then operationalization is similar but different between the clouds. You'll do things the same kind of thing, but you'll do it different ways. You'll use IAM a different way. You'll do that. So that's what I would suggest is the thing to think about your training. Try and do the same thing, but understand that it's not going to be exactly the same. Don't underestimate the human costs of running multiple clouds. Training is like the key thing, and that doesn't mean that you have to go out and do a training course. It just means that you have to spend time investing in your people to make sure they understand how to use all the services available to them in a good way. And my final conclusion would be to leverage the hybrid cloud vendors. So if a vendor is able to do something that you think, I could do that. We use Nagios, we still do. We used it for years, but when we switched to Datadog, and this is not an advertisement for Datadog, it's just an observation. It was very easy to get checks up and running, and they've got monitoring and hooks into all the clouds, and it was great. Like we could see quite quickly a lot more visibility into the other clouds of what we were trying to monitor. So I think from our point of view, we'll be able to offer a much better service off the back of that, because we'll know what's happening. All of a sudden we've got these charts, and we can expose those charts to the support team so they can see latencies and they can start to debug and correlate things for themselves when they get a support ticket. So that's my 4 conclusions for today. I've only got a minute. Any questions? No? Okay, that's all right. I've got some. How long did it take to finish the Golang CLI? Never finished. We are still developing it. And we found that the biggest challenge as the company grows was people. So making sure that everyone was trained and knew how to use things, and that's where our automation really stepped up to the mark. And then the final one, the happiest moment was when we received PRs from the other team on our own internal tooling. That was fantastic. It's like people are using this, reading the code, and supplying fixes for problems that they're having. So that was my happiest moment in regards to this talk anyway. Yes?
I was curious about there was like a runner-up to Golang, and how you can do a little bit more on how you landed on using Golang for your CLI.
The question was there a decision matrix effectively for choosing Golang CLI? Yeah, we considered Java as well. I mean, Java's not traditionally known as a CLI development tool, but we've got a lot of Java engineers, and so there was a consideration there. We considered things like Rust as well, but what we came down to was we didn't have like internally within my team, we didn't have a strong focus on any one platform, so we were going to choose something new that was going to be used by the whole team. Myself, I had a Ruby on Rails background, but I've used Ruby to deploy CLIs, and it just was not pretty. You're trying to get an RVM to work on random hosts, just did not work. So we wanted something nice, static binary, deploys to multiple targets, and so that was how we ended up with Golang. The trade-off between Golang and Java was mainly because of the makeup of my team was not a Java team, and I think we've been proven to have made a reasonably good decision with Golang. Jenkins X is Golang. We've got other teams within CloudBees who are building CLIs for customers through our tooling in Golang that you haven't seen yet. But yeah, that's been good. We've got a bit of a core competency now. And when we acquired CodeShip, their Jet CLI is Golang as well. So yeah. No, we don't use. I think it's Atlas, isn't it? The question was, do we use any management tools for Terraform? And no, we don't at the moment. Why don't we? I think a lot of things we started using it. We predated some of the management tools, and so we started building out this capability before their management tools. And yes, they're solving the problem, and yeah, we should migrate. But it's sort of like our migration to Datadog from Nagios. We could have done it earlier, but we've got 1,000 things to fix. There's always things to fix, so we prioritise. Terraform's done, it's working, it's checking. Right, we've got other problems to solve, so we solve that. All right, well, thank you very much for your time. I hope you've found something useful. If you message me on Twitter or you've got any questions, I'm happy to answer them. I'm on Twitter a moderate amount of time in one of various forms. Happy to chat about that. I'll be out in the conference hall all afternoon. If you've got questions, please come and ask me. I'm happy to answer them. Thank you.